Should we start now or wait for some time?
Hello, sir.
Yeah.
Hello, sir. Good afternoon.
Good afternoon, Ranjit.
Hello. Yeah, you can start, sir.
You can.
Class.
You can.
Now it is 2:22.
Yeah, you can hear me, right?
Yeah, I'll make you speak, sir. Yes, sir. Yes, sir. You're audible.
Okay. Okay. You can see my board.
Okay, sir. Yes, yes, sir. Yes, sir.
Okay.
Chat
Okay.
is coming now. Right now. Yeah. Okay.
You can see my blackboard.
Yes, sir. Galvanometer you have written. It's clear.
Okay. Okay. Fine. Okay.
Okay, sir.
Yeah. Good afternoon. So just waiting for 1 or 2 minutes and then we will start. The completed deleted portions are over. There is no problem. Cyclotron was the last deleted portion that we read. After this, there is very little deleted portion for at least next 2-3 chapters. So don't worry. Yeah. Good afternoon. So yeah, deleted portions are there. So don't worry. Cyclotron is deleted. We were reading that day before yesterday. Voltmeter is all there. So in your syllabus, so we don't have to worry about it. So galvanometer, voltmeter, everything is there. So we just go ahead and read it. Yeah, so let us work with a galvanometer. I already explained to you a galvanometer. I said you take a horseshoe magnet, then again you place a rectangular coil of wire in it. Then whenever the current passes through it, there is a torque. And I explained to you C theta is equal to NIAB. From there, we said that theta is equal to I into NAB by C. Now this NAB by C is referred to as G, the galvanometer constant. Yeah, is referred to as G, the galvanometer constant. And this also gives us the sensitivity of the galvanometer. So it tells us that for a unit variation in I, what is the variation in theta? That is equal to NAB by C. So larger the value of NAB by C, greater is the sensitivity of the device. Okay. Then in yesterday's class, I was talking to you about how to convert a galvanometer into a ammeter. Now an ammeter is a device that measures current. An ammeter is a device that measures current. Okay, so an ammeter is a device that measures current. Now if a device that measures current, it is connected in series. It is connected in series. Okay, so suppose this is a resistor connected to a battery source and you want to find out what is the current through it. So what do? You take the resistor, connect an ammeter to it. An ammeter is a device that measures current. Because it measures current through a circuit, it is always connected in series. Yeah. Now, because it is connected in series, it should have low resistance. Because it is connected in series, it should have low resistance, low resistance. You have an ideal ammeter, should have zero resistance. But ideal ammeters don't exist. Okay, ideal ammeters don't exist. Now, what do? So you take a galvanometer. So this is a galvanometer, and once you have a galvanometer, you connect a low resistance wire to it. Okay, low resistance wire to it. So now when you connect a low resistance wire, the current goes this way. A majority of the current passes through this. A small current goes this way, and then from there, based on the markings that you do on that, you will be able to measure the current. Yeah. Now, yesterday's class, I gave you a few problems. So here I give you one more question. A galvanometer shows full deflection for 100 milliamp current. Convert it into an ammeter measuring 5 amperes if Rg is equal to, let's say, 5 ohms. So can you please work this out? A galvanometer shows full deflection for 100 milliamp current. Convert it into an ammeter measuring 5 amperes if Rg is equal to 5 ohms. So let's write down this question. A galvanometer shows full deflection for 100 milliamp current. Forget about the screen or anything. You just start working and work on your notebooks. A galvanometer shows full deflection for 100 milliamp current. Convert it into an ammeter measuring 5 ampere if Rg is equal to 5 ohms. If the resistance of the galvanometer is equal to 5 ohms. Here is the second slide. Yes, what are the others doing? Quickly give some answer. So the way you draw it is this. This is Rg. That's a galvanometer. So you connect a resistor here. So 5 ohms is 5 amperes is coming this way. This one will be 0.1 ampere. So 4.9 amperes goes this way. So 0.1 into 5 is equal to 4.9 into x. So the x will be 0.1 ampere. I'm sorry, 0.1 ohms. So if you connect 0.1 ohms in parallel, it will behave like an ammeter measuring 5 ampere. Yes, 0.1 ohm in parallel to galvanometer. Yes, are we able to understand? Okay. Others, there are so many, absolutely no response. I'm having doubts. Okay, now convert the same galvanometer to a 10 amp ohm meter, 10 amp ammeter. Convert the same galvanometer into a 10 amp ammeter. Nothing, I'm not writing anything on the screen. There is no screen. Re Baba, question I'm asking now. The first question, did you understand? You didn't understand. Okay, now I'm asking you to convert it into a 10 amp ammeter. That's it. Voice is clear, no? Just convert it into a 10 amp ammeter. No problem, no problem. Okay, I got a Geo phone today. So hopefully from next time onwards, my network will be better. Yes, Apurva, I think 10 is missing. Yeah. Yes, others, there are so many of you all. I'm not sure if you guys are working it out. Abhinav 1010 is coming extra. It should be 0.05. Yes, sir. Okay. 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 Fine. So good. So if you all are able to understand, yeah. So I will proceed. Okay. Now I will teach you how to convert a galvanometer into a voltmeter. Okay. Now I am writing something on the board and I'll write real slowly. So don't worry. Converting galvanometer into voltmeter. Okay. So a voltmeter measures voltage across a circuit. Okay. So it is connected in parallel. So it is connected in parallel across a resistor. Okay. Now, because it is connected in parallel, it should have high resistance. Okay. An ideal voltmeter has infinite resistance. an ideal voltmeter has infinite resistance. Okay, so point number one, a voltmeter is used to measure voltage across a resistor or any element. Now, so it is connected in parallel. Now, because it is connected in parallel, it should have high resistance so that less current goes through it. Now, suppose I have a circuit of this kind and I want to find out the potential difference. So I'll connect a voltmeter here, right? So if I connect a voltmeter across, so it should consist of a galvanometer, and you connect a high resistor to it. Okay, you connect a high resistor to it. So now when you connect a high resistor to it, yeah, I will show you. Here is the previous slide. You finish it off, and then the previous slide for a 10 amp ammeter, I asked you. So it will look like 0.1 into 5 is equal to 9.9 into x. So the x will become 0.5 by 10. So that is 0.05 ohms. Okay, so that's how you will do the previous one. Yeah, once this is over, okay, so once this is over, here is the next slide. It should have high resistance. An ideal voltmeter has infinite resistance. Okay, so now going back again, now you see when the current is going this way, suppose IG is the current through the voltmeter. So IG into RG plus RS must be equal to I minus IG into, or this must be equal to V, whatever V you are measuring. Okay, so from here we want to know the value for RS. So RS is equal to V by IG minus RG, where V is the voltage that you are measuring. So you have to connect a resistance in series to the galvanometer. Connect a resistance in series to the galvanometer. If you connect a resistance in series to the galvanometer, yeah, so this is what you do it. Yeah, so okay, give me a minute, I'll be back. Okay, give me a minute, I'll be back. Yeah, Gokul, I'm making you the host and leaving.
Hello, sir. Hello.
Okay, here is the fourth slide now. Is this visible? So now this is a resistor which is connected to a battery. Suppose this voltage is V, there is a resistance here. So now you connect the galvanometer here in parallel. So you have a resistance here called R, which is connected in series to it, so that when you pass a current, suppose you want to measure V volt, then that Ig, the maximum current which should pass through the galvanometer, only comes here, and I minus Ig goes this way. So when you do that, so you'll get V is equal to, because it's a parallel circuit, Ig into Rg plus R. So now V by Ig minus Rg will give me the value of R. Okay, I hope this is better now. So first tell me whether it is better or not. Yeah, okay. So if it is better now, convert. Here is a question for you. A galvanometer has a resistance 5 ohms and shows maximum deflection for 100 milliampere. How can you convert it into a voltmeter measuring, let's say, 10 volts? A galvanometer has a resistance of 5 ohms and shows a maximum deflection for 100 milliampere. How can you convert it into a voltmeter measuring 10 volts? Whether you require or not, whether it is asked or not, please draw a diagram and then work with it. Array, yeah, now you said it is okay, now it is too much. So Vaibhav, you have to check your internet. Okay, okay. Tomorrow onwards I have Geo, don't worry. Today only I don't have, I just bought the phone connection. So tomorrow I will have Geo. A galvanometer has a resistance of 5 ohms and shows maximum deflection for 100 milliampere. How can you convert it into a voltmeter measuring 10 volts? Okay, so the way you go ahead with it is this. So first you have a galvanometer and you have a resistance which is connected to it. This current is equal to 0.1 ampere. So 0.1 into 5 plus R is equal to 10. So 5 plus R is equal to 100. So R is equal to 95 ohms. So if you connect 95 ohms to it, then it will become it can be used as a voltmeter that can be used to measure 10 volts. Okay. So this is the actual circuit. This is how it is formed. Okay. So it is 95 ohms. Yeah. Others? Okay, so if you are getting it, that is great. Now let us move. There are some small concepts that I want to talk to you about. It may be a little difficult. Don't worry about it. See, here is a resistor. Suppose this is 2 ohms. Here is a resistor. Suppose this is 6 ohms. And you have connected them to a, let's say, a 4-volt battery. Okay, a 4-volt battery. Yeah. Then suppose you are using a voltmeter. Let us say a 5-volt voltmeter. 5-volt voltmeter. Let us say it will show maximum deflection for 500 microamperes. It shows maximum deflection for 500 microamperes. Yeah. Now 500 microamperes means what? 500 into 10 power minus 6. So 500 into 10 power minus 6 means 5 into 10 power minus 4. So 5 into 10 power minus 4 means 0.0005 ampere. Right. Now when you go pass a circuit here, when you pass a current here, because of this, there will be a 0.5 ampere current. Yeah. So now the potential drop here will be how much? Potential drop here will be like 1 volt. Now suppose you connect this voltmeter to it. Look, this voltmeter shows maximum deflection for a very small current. So the current that it is going to take out of the 2 ohm circuit is going to be 0.0005. That means 0.0005, I mean that is maximum, okay, into 2, that is going to be 0.001 will be the error introduced because of the voltmeter. These kind of questions won't come in NCRT. This will come in NCRT. Very good, no problem. Now I am trying to tell you that when a voltmeter is connected, or if an ammeter is connected, an error is introduced. Okay, an error is introduced. So if I ask you, if I give you two specimens, 2 different types of voltmeters, and ask you which one should be connected, so you should be able to find out as to which one should be connected. Okay, so you have to calculate what is the error in this, what is the error in this, and the one which shows lesser error has to be connected. Do you understand the situation? Can you make some notes? This is the previous slide. I am trying to tell you where a voltmeter, or for that matter an ammeter increases the resistance. An ammeter increases the resistance. So it decreases the current. Similarly, a voltmeter reduces the current. Now, because of this, some errors are introduced. So I am trying to make you sensitive to that error. So I am trying to make you sensitive to that error. So what is the error which is introduced? Are you able to understand? Here is the last slide. Here is the penultimate slide. This is slide 7. Here is slide 8. So do you understand this concept of error coming in when an instrument is added to it? How to find the error? Yes. Suppose a voltmeter is added. So the voltmeter is going to take some current. So I galvanometer. Yeah. So actual potential difference is equal to I into R. Measured potential difference I minus Ig into R. So error is equal to Ig into R by I into R. So it is Ig by I into 100. So this is Ig is the current. Ig is the current drawn by the voltmeter. I is the current in the circuit. So this Ig by I into 100, that is the error which is brought about. This error can come in any format. This is the error when a voltmeter is introduced. If an ammeter is introduced, this is the additional resistance. This is the final resistance. This is the final current. Previous current is V by R. So V by R minus V by R plus Rg into Rs by Rg plus Rs. This is the change in current. So this is the error in the measurement of current because of this. V by R you can take common. So you have 1 minus 1 by 1 plus Rg Rs by R times Rg plus Rs. So this will go up. When this will go up, it will become 1 minus 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 will become plus. So it will become V by R into Rg Rs by R into Rg plus Rs. So this is the error. Because Rs is very small, the error is very small. This is the current after connecting the voltmeter. This was the current before connecting the voltmeter. The difference between the two will give you the error. Yes, any progress? Do you understand? I don't know whether you guys are silent because you are sleeping or you are not. You are really understanding. Yes. Okay, so tell again. Okay, so I will tell again. I will go to new slide and tell again. Statement 1. If I connect voltmeter or ammeter, the current in the circuit, I in the circuit changes. Okay, so an error is introduced. If the current, if I connect a voltmeter or ammeter, the I in the circuit changes. So an error is introduced. Okay, now I am explaining to you how. Suppose this is a resistor which is connected to a battery. Now there is some I. That I is equal to V by R. Okay. Now if you connect a voltmeter to it, some current Ig goes this side, some current Ig goes this side. So the current here is reduced. So the new potential difference is I minus Ig into R. The old potential difference was I into R. So the difference is delta V. So delta V is equal to Ig into R. Delta V as a percentage divided by I into R into 100. R gets cancelled. So it is Ig by I, the ratio of the current passing through the galvanometer versus the current in the circuit. So this is the error introduced because of a voltmeter. Same way, if there is a circuit here and if there is a thing here, I is equal to V by R, whatever it is. Now suppose this is an ammeter. Now an ammeter has some resistance. So the new current I is equal to V by R plus R ammeter. So now you see there is a difference in current, this minus V by R plus R ammeter. So if you take LCM there, so it will become V into R ammeter by R into R plus R ammeter. Okay. So if R ammeter is small, then it is equal to V by R square into R ammeter. So this is the error in Now if I want to find the percentage error divided by V by R. So V R gets cancelled. So here R ammeter by external resistance. So this is the error. So when you connect an ammeter in a circuit, ensure that its resistance is very small when compared to external resistance. Okay, then when you connect voltmeter, ensures that it draws very little current when compared to the external current. Okay, so how can you make it small? By making Ig small. How can you make Ig small? By having a high resistance in series to galvanometer. In this particular case, how can you make Ra small? Ra is equal to Rs into R by R plus Rs into capital R. So here this is Rg. So this Rs will be made very small. So if RS is very, very small, then error will be very, very small. Okay. Hey, tell again. Now you're telling or earlier tell again. Okay. Yes, sir. So please others, please put some message. Anyway, I'm not going to tell again, but at least let me see some how many of you are awake. 12 of you are awake, 13. Okay, okay. Now some of you are awake. Okay, good. Okay, fine. Yeah. So this covers this concept of voltmeter, ammeter. Okay. Again, I have not discussed 100%. I have percent. We can do some more questions, inner aspects of it. Say, for example, one fine aspect I can discuss right away. So let me ask you guys a question. Okay, just 1 minute. I will ask you a question. Just 1 minute. So they have removed color coding from your syllabus. Okay. So you don't have to read color coding. A second, 1 minute. Here, more questions. The resistance meter is 50 ohms and max current is 0.002 ampere. What resistance must be connected to convert it into, this is 2019 JEE mains question, convert it into ammeter of range 0 to 0.5 ampere. One effort, within 2 minutes, give me an answer. Very simple question. The resistance of a galvanometer is 50 ohms and max current is 0.002 ampere. What resistance must be connected to convert it into an ammeter of range? Okay, so let me check if there are any fast movers. No, color coding is never there in JEE. Options are 200 ohms. Sorry, options, I don't know. I can do it for you. So I will work it out for you. Only 4 people have responded. So I will work it out for you. It should be converted into an ammeter, right? So so 0.002 into 50 is equal to 0.5 into x. So 5, so this is divided by 0.5. So divided by 0.5, na, this will become 100. So 0.2 ohms. Yes, so that is the answer. I was not speaking, only now I am speaking. Waiting for you guys to work it out. Yeah. So 0.2, Ashwin, some error. Yes, Harini, are we able to get it? Yeah, okay. So if you all are getting it, only some 10-15 of you are working, the others are all sleeping. Okay, so one last question. This is a JEE 2021 question. We got this recently. You always get one question from here. A moving coil galvanometer. The galvanometer that we had a moving coil. So it's called a moving coil galvanometer. A moving coil galvanometer allows full deflection, full scale current of 10 power minus 4 ampere. A series resistance of 2 mega ohm is required to convert it into 5-volt voltmeter. What is the resistance that should be that should be added, that should be connected to convert it into an milliampere. 2 mega ohms is required milliampere. 10 milliampere resistance. Yes, screen is not visible for anyone. Now screen is visible. Okay, so any answers for it? There is nothing that I am doing, so there is no screen stuck or anything. There is only I gave you question. I'm just waiting for answer. That's it. Here is the question. A moving coil galvanometer allows full scale current of 10 power 4 ampere. A series resistance of 2 mega ohms is required to convert it into 5 volts. 5-volt voltmeter. What is the resistance that should be connected to convert it into an ammeter? 10 milliampere. So 10 power minus 4 into Rg plus 2 mega ohms. Yeah, this is equal to 5. So from here, Rg plus 2 mega ohm is equal to 5 this much. Okay. One minute, I'll just check whether it is really mega ohms or what it is. Something seems to be little error. Yeah, so this is a wrong question. Basically, it should have been kilo ohms or something. Why? I'll tell you, because mega refers to 10 power 6. So if the moment you put 10 power 6, Rg will become negative. So this is a wrong question which came in the exam, but we can still work it out. You just say, so, okay, please understand the logic. So first you get the value for Rg. Now, once you get the value for Rg, now you have to see what you can do to convert it into 10 milliampere. 10 milliampere means Rg into 10 power minus 4 must be equal to 0.01, sorry, in 10 into 10 power minus 3, that is 100 into, so it will become 99 into 10 power minus 4 into Rs. So now Rg you calculate from there, these two will get cancelled, so it will become Rg by 99 should be the value for Rs. So that is how you can work it out. Okay, but there was an error in the question. The numerical value that they gave was wrong. So everybody in that exam would have got marks for it. Yeah, minus, yeah, correct. So what Soumya has done is the correct thing. So negative value comes. So everybody would get marks for that. Okay. Yeah. So I hope we are able to understand. I have completed this concept of voltmeter, galvanometer, converting galvanometer to voltmeter, converting galvanometer to ammeter. This is a very, very important concept. You get 5-mark questions also. You get questions in the JEE mains also. This is not removed from your syllabus. Full thing is there in your syllabus. Okay. Okay. So if you get it, I can show you my slides and then we can go and properly sleep. So here it is. First slide. Quick recap. Second slide, telling you what an ammeter is. It measures the current. It is connected in series. Then I told you about an ideal ammeter. An ideal ammeter has zero resistance. A galvanometer shows full scale deflection for 100 milliampere current. So convert it into an ammeter measuring 5. I did some problems for you. So then I taught you how to convert a galvanometer into a voltmeter. So very neatly I wrote down and I explained to you. Yeah, we did few more questions. Thirteen, then 14. Yeah. Okay. So bye. Yeah. Thank you.